So as I promised, guys, we are now going to look at a nice example where we use first principles to find the gradient. Just the one thing to highlight or bring to your attention, when we look at this point A here, guys, where the tangent touches the graph, actually the notation, if we're gonna, obviously there's an x value here for A. So if I write f prime of x, okay, that is referred to as prime. You can read it as prime or you can read it as derivative. But actually, because we are not really here on geometry, I think it will be proper to say the derivative, okay? And actually, this thing tells me about the gradient of the tangent. But at the same time, okay, what I must understand is that now when I talk about f of x, these are not this one and the same thing. These are two different things, okay? This here tells me about the gradient of the tangent to this function at a particular point, okay? Here, I can just get the y value of the function at that particular point. So that is the subtle difference, really, that I think I've seen a lot of students battling with, and I thought I should just bring this, guys, to your attention so that you can get an appreciation or a clear understanding of what the first derivative or first principles is all about. So let's go ahead here and find from first principles the gradient of f of x at any point. So I know you will get used to this, but I think it is given in your final exam. From first principles, the gradient of the tangent, or the gradient rather of this function, we're not finding the what, but it's the same thing anyway. The gradient of the function, okay, at any point, okay, is the limit of f of x plus h minus f of x over h as h tends to 0, as the distance, as you saw, the distance here gets smaller and smaller. Now, this is the limit. My advice really is that you should kind of figure out first f of x plus h, and f of x will be usually given, then just substitute, because I've seen students getting confused here. So let's figure out what x plus, or what f of x plus h is on the left here. Remember, f of x is x squared, okay? Is x squared. Let's take that. Actually, it's not really x squared. It is x squared plus something. It is x squared plus 2x plus 1. So that's what we're going to find. So f of x plus h in this case, and of course, I'm taking a very sort of difficult example, if you may say, but it's worth a try. So f of x plus h, you see here, where you have x, there's x there. So here what I'm going to do, where I see x, I must actually put x plus h. Then I must square that, as in there, plus 2 into x plus h plus 1. Then this thing is x squared plus 2h plus h squared, right? As I said, these are one of the things that you must really master now. This is 2x plus 2h plus 1. So this entire thing is your f of x plus h. So now let's come back here and substitute. So I know that my f of x plus h is as follows. You see, I'm going to group the like terms here. So it's going to be x squared plus, you can see the 4h plus h squared, okay, plus 1 minus, what am I subtracting? Now it's important to put brackets, x squared plus 2x plus 1. This is all over h, right? And I simplify, this is the limit, right? So h tends to 0 of x squared plus 4h plus h squared plus 1 minus x squared minus 2x minus 1. You can see x squared takes care of x squared there. This one also takes care of that one. And well, I'm dividing by h, and then so I am left with the following on the numerator. I am left with h squared plus 4h here minus 2x. Yes. And obviously, this is all over. Actually, I forgot a 2x here. This should have cancelled that out. You see, this 2x should have dealt with that 2x. So I am actually wondering why it hasn't happened. So now I see. Yep. So this 2x should have dealt with that one. There it is. That's the 2x that we had. So I hope you can see that. I've not really manipulated anything. So that takes care of that. And I'm left with an h as h tends to 0. And I can now factorize. And I have h into h plus 4 over h. And this is the limit as h tends to 0. You can see I'm now left with h plus 4, so I can substitute and say 0 plus 4. This is equals to 4. And the principle here is you are never going to find yourself dividing by 0. If you find yourself dividing by 0, then the limit does not exist. Probably we can say the gradient is undefined. And so that means you are having something like a line that is parallel to the y-axis, because that's the only case where we have the gradient undefined. So that's the story, guys. That's how you're going to use this thing called first principles. Okay. Let us just try and have another look at this nice simple example. For example, let's take f of x equals to 2x plus 1. From this, we can see that the gradient is what? Is 2. Now, let us see if first principles work. Well, f of x plus h is 2 into x plus h plus 1, and this simplifies to 2x plus 2h plus 1. Now, let us quickly see if this will work, okay? What is the limit of f of x plus h minus f, all right? Minus f of x over h as h tends to 0. We are expecting a 2 because that's the gradient. So let's see. This will be 2x plus 2h plus 1 minus 2x plus 1. You see, very, very important to put brackets. And of course, I forgot here to put the limit and say this. It's very important, very, very important. So you can see already I've got 2x plus 2h plus 1 minus 2x minus 1 over h. 2x covers 2x, 1 covers -1, and I am now left with, I'm just going to write somewhere here on the left, so I'm now left with the limit, okay, as h tends to 0 of what? 2h over h, and h takes care of h, and so I'm left with a 2. And that is exactly what I was anticipating for this straight line. So you can see the gradient of this function, okay? And so remember, I should have started here by saying f prime of x is equal to the gradient of this function is the first derivative in principle, okay? And that's how we can use this newly discovered technique to find it. I hope, ladies and gentlemen, you are restful wherever you are, and you are able to use this to find a whole lot of things as you continue with this journey of calculus. In the next few videos, I think we're going to look at the rules of differentiation and investigate them and see, just to find out where they come from and how can we use them instead of using this long route. In other words, we are going to look at now shortcuts of finding the derivative of any function without going this long route. Cheers.